Hello students, welcome to our new lecture. In our today lecture we are going to discuss that how can we estimate the OLS results and how can we interpret the results. So first of all we have to bring our data into EViews file for the estimation purpose. So for that we have to open the EViews and we have to click on create new work file, and after clicking on create new work file I have to select the pattern of my data. As I have my data annually, so I have to click on annual. So after clicking on annual I have to mention the start and end date of my data. So then I have to enter the end date of my data, which is 2020, as I have written here that my data ends in 2020. And in this column as you can see that there are three options: unstructured, dated, balanced panel. Unstructured means that if your data have no start and ending date. Dated means that your data have start and end date. Balanced panel means that if your data in panel form. In our coming lectures we will discuss that how to create panel data and what is meant by panel data. But at the moment we have data in dated and regular frequency, so I have to select this option that my data is dated and regular frequency. So after this I have to click on OK, and then I have to go to quick, and then I will go on empty group, and after that I will go to the Excel sheet and I will select all the data which I want to bring into the EViews file. So this is my data and these are my three variables. So I am going to select all of these variables, and after that I will press Ctrl C in order to copy the selected data, and then I will go again to the EViews file and I will paste the copied data here. As you can see that all the copied data is present here. So after bringing my data into EViews, there are two ways for the estimation of OLS. One method is you can do it by command method, and the other method is that you can do it by another method without using command method. So let's discuss about how to estimate OLS by using without command method. So for that purpose I have to go to the these of options in order to estimate OLS without using command method. I have to go to quick, then I will go on estimate equation. In this panel I have to write that what are my dependent variable and what are my independent variables. As for example, I will take that GDP, the gross domestic product, is my dependent variable. So the rule is that you have to write your dependent variable very fast. So GDP is my dependent variable, so I have to write GDP as first. C is as constant or the intercept if you want to include intercept in your data. Then I have to write all other variables one by one. Like ED is my second variable. Then I will press the space button and I will write the second variable. Then I will again press the space button and then I will write the my third variable. So in this equation, it is representing that this is my dependent variable and these three are my independent variable ed, fa and fdi. These are my independent variable and c is constant or the intercept which is present in this model. You can take your model without intercept, but in this model I am going to take intercept in my model. It is up to you that whether you want to include the intercept in your model or not. And after deciding that which one is my dependent variable and which one is my independent variable, then I will go here. As you can click on here, there are multiple options that which of these techniques you want to include in your model, which technique you wish to put or estimate on your model. So as we are discussing about OLS method, so I will simply click on LS and then I will LS mean least square method, and then I will simply click on OK and it will give me a result of the OLS, which is ordinary least square. So as you can see that this is the result of simple OLS method. So now we will discuss that what are these results are showing. As you can see that here is the dependent variable which is GDP. As I mentioned that click the variable first which you want to, which you wish to treat as your dependent variable. As in my data I have selected GDP first, so GDP will be my dependent variable. And this is showing that method, which method you have adopted for the estimation of these result. As we have adopted or we have used least square method, so it is showing us that you have used least square method for the estimation. And this is showing time period and what time is, and this is showing what is our sample size ranges. Our sample size is ranges between 1980 to 2020, and this is showing that how many observations are present in our data. So now let's come to the this part of the table. This column is showing that what are variable which are being used in our estimations. This is showing the coefficient value of these estimator. This is standard error, t statistic and probability value. So this coefficient is showing that how much variation in the dependent variable because of this independent variable. As we discussed earlier that C is a constant or C is a intercept which is showing the average value of the dependent variable when all other variables are 0. But at the moment we have we have the positive values or non-zero values for our independent variable. So we are going to discuss that what are these coefficient values tell us. As you can see that this variable ed mean external debt, its coefficient sign is positive. So it means that there is a positive relationship between GDP and ED. When ED increases, GDP also increases. We are not considering the exact theory, what is true theory, but at the moment we are just interested in how to interpret these results. So this positive sign means that there is a positive relationship between GDP and ED, which is external debt. And what does this 0.88 mean? This means that when there is a increase in ED by 1 unit, it will increase the GDP by 0.88 unit. Okay. And what does this t statistic mean? T statistic mean it shows that your this coefficient results are significant or not. What is the rule of thumb? The rule of thumb is that if the t value is greater than 2, then it means that your results are significant. There is one another method for checking that either your results are significant or not. You can check it by the probability value. If the probability value is less than 0.05, it means that your results are significant. As you can see that here our probability value is very much less than the 0.05, which means that our these results are highly significant. So for the true relationship between these dependent and independent variable, it must be considered that your sign of this dependent independent variable with this dependent variable must be accurate to the theory, and probability value must be less than 0.05, and your t statistic must be greater than 2 for the significance of your this variable result with your dependent variable. So next, let's talk about this another variable which is FA. FA coefficient is also positive, which means that there is a positive relationship between FA, which is foreign aid, and GDP, which is gross domestic product. It means that when foreign aid increases, GDP will also increases. We are saying this because of here as it is has positive sign. So by considering this positive sign, we are stating that there is a positive relationship between FA and GDP. And what does this 0.275956 mean? It is the coefficient value. So it means that when there is a increase in FA by 1 unit, it will increase the GDP by 0.275 units. So now let's discuss that whether it is significant or not. We have to check the t statistic value. If t statistic value is greater than 2, then it means that this coefficient is showing a significant relationship with the dependent variable. As our t statistic value is greater than 2, which means that our these results are significant with our dependent variable. And we also have to look at the probability value, and for the significance of this result, the probability value must be less than 0.05, and as you can see that our probability value is very much less than 0.05, which means that these results are highly significant. And our last variable is also showing a positive relationship with our dependent variable as its coefficient sign is positive. So it means that when FDA increases, GDP also increases, as here is a positive sign. And its coefficient value explain that when FDI increases by 1 unit, it will increase the GDP by 0.06 units. And for the significance, we have to check the probability value and the t statistic value. But when we look at t statistic value, it is less than 2, and probability value is greater than 0.05, which means that FDI is not showing us significant results on the GDP. Why it is so? Because t statistic is less than 2 and probability value is greater than 0.05, which is the violation of the rule. According to rule, this t statistic value must be greater than 2 and the probability value must be less than 0.05 for the significance of the results. So now let's discuss the below part of this table. What does this mean R square? R square value shows that how much variation in the GDP is because of these three variables. Okay, R square shows that how much variation in GDP is explained by these three variables. It is 0.95. So it means that 95% of the variation in GDP is explained by these three variables and 5% variation is explained by some other variables. And what does adjusted R square mean? Adjusted R square means that when you include or exclude any variable into your data, that variation is explained by this adjusted R square. And for the stability and for the significance of the model, your probability F statistic value must be less than 0.05. So it means that your overall model is good fitted. So as our results indicate that our probability F stat value is this less than 0.05, which means that our model is good fitted. And if you want to check the problem of autocorrelation through these results of OLS, then you have to look at the Durbin-Watson test results, which is sometimes called DW test. So if its probability value is in between 1.5 to 2.5, then according to rule of thumb, there is no problem of autocorrelation in your data. So in these results, our Durbin-Watson probability value is less than 1.5, which means that there is a problem of autocorrelation in our data. So this is all for our today lecture for the interpretation and the estimation of the OLS results.